Yes, we are back, and today we are in simple machines. This is our question, which was in PLR 2015, and says the diagram below shows a simple machine. Primary 7, I have been showing you my reference books, which I said I can give it to you at about 35,000. So this is our machine, and I also have machines here. This is the machine that we are having today, the way it looks like this, okay? And it is the one where you name extracted the item. Let's look at part A. To which class of levers does the machine above belong? Now, we want to look at classes of levers. And you remember, for you to be able to know the class of a lever, classes of lever, we use PLR, where this one represents effort. I know most of you have been in P7 know. And this represents Lord, not the Lord Jesus Christ. And this represents pivot. Sometimes they put F and then it represents fulcrum. Are we together? Now, we want to first identify where do I find effort? Where do I find load on this machine? Number one, when I'm cutting, what I'm cutting is here. So this becomes our load. And therefore, it means my load is here. Okay? Then, when I want to find out fulcrum. Now, fulcrum is the turning point. Fulcrum is the turning point. You can see. So it is turning from here. And therefore, this one becomes my fulcrum. Fulcrum, which we can also call a pivot, which we can call a turning point. A turning point. And then we have this side where I'm applying. If I'm trying to cut this finger, I apply effort here. I apply effort here. And therefore, this one becomes my effort. Now, I come back to PLE. If pivot or fulcrum is between the load and effort, that one becomes first class. If load becomes in the middle of pivot and effort, it becomes second class. And if effort is between the load and the pivot, you go to third class levers. So let's look at this one. We have effort, we have in the middle fulcrum, and then we have load at the end. So you realize that fulcrum or pivot is between the load and the effort. Between we have pivot or what we can call fulcrum. And this makes it to be first class levers. I think it is very clear. Now, what shows that this machine belongs to the named class of levers? We're just going to say because pivot lies between load and effort. Just like we have seen it here. We have pivot in the middle, and this here we have load, we have effort, and fulcrum is in the middle. As simple as that. Then or someone can say fulcrum is between load and effort. Or someone can say a turning point lies between load and effort. You can use any word as long as you don't miss the key concepts of pivot being in the middle of effort and load. That is what gives you the answer. Use an arrow with the letter P to show the fulcrum on the machine. We have already identified the fulcrum is here. So you are going to make your line and say, they have said which letter? A letter P. So we put P here. It is here. This is the arrow that I have used. This is the turning point. Even on my machine, this is the turning point here. You can see this is where the machine, this is the blade, and this is how it turns. It is turning from here. So this becomes my fulcrum, it becomes my turning point, it becomes my pivot. Now, part D, how can the effort needed when using the scissor be reduced? It is very simple. Number one, you sharpen the blades. Make the blades sharp. Sharpen blades. If this scissor is blunt, you need a lot of energy to cut. And therefore, if you sharpen these blades, these ones, you sharpen them very well. You just come say, chick, chick. Number two, usually when you cut from this end, it is harder. But if you cut the material near here, near the pivot, it is easy. So you can say cutting the load. Should I call it load? Or the material near the pivot. Near the pivot. If the item is near here, you easily cut. All of you are going to go and test this with your real scissors and try to cut near here and cut here. You'll see where does it become easier to cut. Number three, you see this turning point. Sometimes it is very hard to turn, and the easier it turns, the quicker you cut. Which means, if for example, if I oil the pivot, I reduce friction, and the scissors move easily. That is also another one. If you add some oil here, it becomes so easy to be able to what? To move quickly without a lot of struggles. And therefore, if it can be able to slide over one another quickly with this friction, now you can hear mine. Okay? It's producing some sound. Why? Because there is a lot of friction between the two blades at the turning point. And then maybe the last one you can do is increasing the length of the handles. There are very many other ways, as you are going to highlight them in the comment section, plus the questions. How does the oiling, we have already talked about this. How does oiling the pivot improve the working of scissors? It is very simple. You reduce friction. And hence, the blades move easily. As simple as that. If you have any questions concerning simple machines, especially with the first class levels, please drop it on our number. We will be able to answer your question. Do not forget to subscribe. If you forget, you will not get alerts of new content uploaded. Even when you send your question, you will not know when we have answered your question. Subscribe to our YouTube and you will not regret. Thank you very much.